Do you ever wonder why time just seems to go faster as we get older and older, or maybe why worms seem to regenerate their entire bodies when we cut them in half? Well, I don't know either, so let's find out. Usually, when I think of the acceleration of time seeming to just fly by as you get older, the first thing that comes to mind for me is just a math viewpoint of it. Obviously, time moves the same speed no matter where you're at in the universe, wherever you're at on Earth, anything, how old you are. So, but generally, if you think about it this way, like if you're 2 years old, right, 1 year of your life is half your life. So, being two, you've already lived half your life. So, when you're like 10 years old, 1 year is 1/10 of your life. So, it seems like such a big portion of your life that when a year passes by, it's just like that's your whole everything. But when you're like, say, 60 years old, 1 year's only 1/60th of your life. So that's when you can think like, okay, maybe it's just seeming more meaningless as you get older and older. This is how I interpreted it. I'll have a link to the article in the description, but basically what I think, my interpretation of what he's trying to say in his article is essentially that as you get older, your brain can't process images as clearly or as often as it usually does when you're younger. So basically by getting older, it slows down the speed at which you're processing images. This usually means that instead of getting, say, a new piece of information every millisecond, you're getting it maybe every 5 milliseconds. So there's less details to refer back to. So what I'm thinking is maybe when you're younger, there's so many more details, so it's easier to draw back on these memories, or maybe even seem like it's longer, because if you have more information, it's easier to draw it out. So when you're older, you have less information to refer back to when you're thinking of memories, because your brain generally just processes slower. It's not as good as it once was, maybe from wear and tear, maybe just from getting older. That's just how it is. A good metaphor for this, in my opinion, would be a time lapse, where a time lapse is taking a picture, say, every 5 seconds, maybe 10 seconds. It seems like the thing that you could accomplish in that time occurs so much faster when you combine all these images, because you're leaving out information, so you're just getting the general idea of it, but not every single detail. So as you get older, your life's more like a time lapse versus when you're younger, you're living kind of in the moment, everything's passing by. What I found interesting was the fact that he got this conjecture, this idea, basically from the fact that infants' eyes move much more frequently than adults' eyes. He noticed that babies will be just looking all around, getting so much information in, whereas adults kind of just generally tend to keep focused. This could obviously be, linked to something else, but I think that's cool how he thought that's maybe why, and perhaps that could even link to the fact that when you're asleep and you're in REM sleep, this is just my opinion, but maybe like your eyes moving, all that, that's just because you're processing all this information, because it's called rapid eye movement sleep. That's how you process information. So maybe the eye movement could also be linked to processing information. That's just my idea. I don't know. Moving forward, another cool article I found. It's titled "Scientists Grew a Mini Brain in a Dish and it Connected to a Spinal Cord by Itself." Essentially what they did was they took a bunch of neurons from a human and they made like a pea-sized brain, homemade, their own. But the only thing is it's not, they're definitely not as strong as a human brain or as powerful because of how small it is, but it's still a brain. They then placed this brain, next to a mouse spinal cord and muscle tissue, and it's been quoted as like stretching out a little tendroid, they called it, and attaching to the spinal cord and the muscle tissue, which I think is crazy that the brain was aware enough to stretch out and connect to these things, possibly making a creature, Obviously not on that sense, but it's kind of interesting, I think. It was even described as spontaneously connecting to the spinal cord. Like, it was instant. It was almost like the instant they put it in that situation, it just decided to attach. Almost like being sentient in a way. Another interesting fact is the fact that they say the way they make them is through human stem cells, and like they just place them in there with some brain matter and it begins replicating and creating this thing. It's almost like evolution at play. Like, maybe give it 50 years, like a long enough amount of time, maybe a brain could be made. I don't know. The funny thing about this all to me is the only thing I could picture, like when I first read it, about the whole brain connecting to the spinal cord and stuff, is just like, could you imagine just like a little rat creature before you just like coming to life, all because you just threw a little pea-sized brain by it? Like, kind of weird, and it's kind of some creepy stuff. And branching off this idea of, something connecting or growing, this kind of relates back to the worm thing that was referring to in the beginning, because this article by the New York Times actually says if you chop up a worm, it'll regenerate, and scientists finally figured out why. So obviously everyone knows that like if you cut a worm in half, or for the most part, if you cut a worm in half, it'll tend to grow another body where the brain was. But no one really knows why. It's kind of like a mystery at this point. What the scientists relay it back to, they think, is just one single gene for the most part responsible for the regrowth and, refunctions of the worm. Like, they're basically implying that due to this one gene, you could cut a worm in half, thirds, fifths, anything, and there would be that many worms. However many halves there are, wholes or fractions of the worm there are, they, because of this gene, should grow into that many worms. I haven't looked into how worms reproduce or anything, but I'm assuming maybe it could be a thing similar to starfish, how starfish reproduce by, I think it's called budding, where they like a piece of them kind of falls off and becomes another thing. That's how they reproduce, almost like cellular division, but on a huge macro scale. Maybe that's how worms reproduce. I don't know. But what I think is cool is the fact that they have this ability to regrow things like with a gene, not even like a special stem cell or something. Like maybe implications of this could come to humans. Like someone loses an arm, you could single this gene out, maybe splice it into a human because we have capabilities of that now, at least for the most part, like with CRISPR and stuff. Maybe you could have people regrowing their limbs. I don't know. The future is kind of crazy to think about right now. A cool question, or maybe even like dilemma this arises is, okay, if a human were to have been birthed or spliced with the gene of this, and you were to cut someone down the middle, would that form two people? Would there be a clone of you? Which one would have your memories? Which one would, I mean? Like, I don't know how that would work out, but that's like a cool thing to think about. Reading further into the article, it actually seems like they are trying to find implications, like I was saying, of human limb regrowth. So that's like the coolest thing ever. I think another thing this reminds me of is like how, I don't know if you guys know how telomeres work, but basically what they are, it's the end to your, it's the end of a chromosome. And basically, every time your body replicates cells, the end of your chromosome, part of your DNA, almost in a way, kind of shrinks away. Like, just it's almost like not friction, but just wear and tear. It kind of just over time gets smaller and smaller, and that's why you see signs of aging, like your hair getting gray, stuff like that. Well, the thing about lobsters is theirs doesn't mess up. They technically could live forever if they never got diseases, weren't overfished, something like that. If you just leave one alone by itself in a clean, safe environment, it will live forever. So I think with the combination of this worm gene and possibly the gene that allows lobsters to live forever, we potentially could see humans living forever. But obviously with humans living forever, that's a huge dilemma in the fact that, okay, Earth's running out of space. How are you going to fit infinite people? There's going to have to be like regulations, laws, maybe preventing birth. If everyone can live forever, it's almost like, I don't know, there's a lot of moral dilemmas within that. I know that me, for a fact, I wouldn't want to live forever if my friends and family weren't living forever, because you wouldn't want to have to go through the sadness of seeing people pass by. And not to mention, I remember a Neil deGrasse Tyson interview, the astrophysicist, he was talking about how if you could live forever, you would have no ambition. And I kind of agree with that, because it's like, if you could live forever, you'd always think, oh, I have tomorrow. You never would think, okay, I need this deadline due at a certain time, because you would have no ambition of that. It's like time, in a way, causes you to work harder, and having constraints makes you work harder. I feel like we would progress less living forever than we would having a deadline. And he said most of that, but I agree fully with that. That's about the extent of the articles I found for this week. I plan to keep this series going if people enjoy it. I, for one, like learning more about this stuff. Anyways, thanks for watching. It's been Bold Assumptions. I'm out.